Okay guys, we're going to go ahead and learn about the unit circle here. And first thing we want to mention is the special triangle stuff that we had just learned previous to this. And remember that in the 30, 60, 90 triangle, if the long side is 1, the hypotenuse is 1, then the shortest leg is half of that, which would be a half. And then the long leg is root 3 times the short leg, which would be root 3 times 1/2, or root 3 over 2. And the same thing with the 45, 45, 90. If the hypotenuse is 1, then you would divide by root 2 to get to your leg, and dividing by root 2 and rationalizing would get you to root 2 over 2. Or if you think about it this way, root 2 over 2 times root 2 would be 2 over 2, which is 1. So really, we worked with those special triangles so that we could go ahead and use them within the unit circle. So let's go ahead and take a look at what this unit circle is all about. Okay, so what we're going to do with the unit circle is essentially start to define sine, cosine, and eventually tangent values of more than 90 degrees. That's why we're going to use a circle. So you see here I have a whole bunch of stuff. I have a bunch of different triangles and values and such. And so what we're going to really do here is we're going to go ahead and put a triangle inside this circle. And we are going to make mention here that the unit circle will have a radius always of 1. So this triangle is going to have a hypotenuse of 1, which is also the same thing as the radius. So the radius of the circle is 1. And you know from our special values, special triangles, that if the radius is 1, then, or the hypotenuse is 1, then the short leg is a half, and the long leg is going to be root 3 over 2. So what this tells us then is some cosine and sine values. With a hypotenuse of 1, it becomes pretty easy to compute. So if we look at a cosine value here, that is going to be, if you remember cosine, that's adjacent over hypotenuse. The adjacent side is the root 3 over 2, and the hypotenuse is 1. And you know that anything over 1 is just whatever it is. So root 3 over 2 over 1 is just root 3 over 2. So the cosine value of 30 degrees is always root 3 over 2. So what we're going to do on this unit circle, this is like a coordinate grid. So this would be like the origin right here, 0, 0. If I go all the way to the right over here, to this first point, this will be our first point here. This is equivalent to the radius, which is 1. So if we plop this point in here, this is equivalent to the radius, which is 1. And it is up on the coordinate axis 0. So this is the point 1, 0. Okay, so that will probably make a little more sense later on. The point up here, if we go to our unit circle, and the first point that we come across on our unit circle is right here. And what we're going to do then is use this point to identify, because if this is an ordered pair where I put this star, that would be to the right root 3 over 2 and up a half. So if I go ahead and list that as an ordered pair, that would be to the right root 3 over 2, and it would be up 1/2. So this would be like the point root 3 over 2, 1/2. Okay, and notice that what we did was we just talked about the cosine of 30 degrees as being root 3 over 2 over 1. So this is going to be the cosine value, which essentially is your x value. And your sine value is the same thing. The sine is opposite of 30 degrees. That's 1/2 divided by 1, which is 1/2 over 1, which is 1/2. So the sine of 30 degrees is 1/2. So if you typed in the sine of 30 degrees in your calculator and hit enter, it would give you 0.5. Okay, so there's our first stop on the unit circle. And this is information that we've already worked with this stuff, really, with SOHCAHTOA. The next value on our unit circle is going to be 45 degrees. So we have traveled from here up to here, that's 30 degrees. So if you think about the circle, and we go counterclockwise around the circle, so if you think about the circle going all the way around the circle, what is one full revolution all the way around the circle? That would be 360 degrees, right? So we start to think about these values. This would be the value 30 degrees, okay, on the circle. And our next value, if we go 45 degrees from the horizontal, that's going to be located right up here at 45 degrees. So that's our next spot on the circle. And so what are the cosine and sine values there? Well, remember, our hypotenuse is 1, and that means that our side lengths here of the legs of this 45, 45, 90 are both going to be root 2 over 2. So that means the cosine of 45 degrees is root 2 over 2 over 1, and the sine of 45 degrees is also root 2 over 2 over 1. So they're both the same. Both of these values are going to be root 2 over 2. So the cosine of 45 degrees is root 2 over 2 in radical terms. In those tables we looked at in the previous video, they were in decimal. But here we're leaving it all in radical. So the cosine and sine of 45 degrees are both the same thing, root 2 over 2. And so this right here is 45 degrees on our unit circle. The next stop on our unit circle would be 60 degrees. And 60 degrees, it's the same thing as a 30, 60, 90 triangle. So again, the hypotenuse or the radius of the circle is 1. And we have our same values. And these values we get pretty familiar with. So the value opposite of 30 degrees is 1/2. And that represents the cosine. Because the cosine is 60, this is the adjacent side divided by the hypotenuse is 1/2 over 1. So what we end up having here is our next spot on our circle, 60 degrees. And the cosine value is essentially your x-coordinate, which is 1/2. And your sine value, which is your y-coordinate, is going to be root 3 over 2. And so what we just determined there is that nothing we don't know already. Cosine of 60 degrees is 1/2 over 1, which is like the x-coordinate, which is 1/2 to the right, and root 3 over 2 up, which represents the sine value because opposite of 60 degrees is root 3 over 2 over 1, O over H, so opposite over hypotenuse, that's root 3 over 2. So what we're going to do is we're going to generate all of our values all the way around the circle using these three angles. Okay, so now we've come all the way up to the top of the unit circle, and at the very top is 90 degrees. So up here is your 90 degrees. And you know, we haven't really talked about 90 degrees as a sine and cosine value. The values were on the tables, but you know, it doesn't really apply so much to a triangle when you start getting above 90 degrees, or at least right triangles, because the biggest angle is 90 degrees. So that's what we're going to do, is we're going to start talking about sine and cosine values of greater than 90 degrees. And that's essentially what we're using this unit circle for. So if you think about our x and y coordinates, the cosine is your x coordinate. So this is not to the right or left at all. So the the cosine of 90 degrees is 0, and the sine of 90 degrees is going to be 1. So that's all the way up, the full radius 1, and it's not to the right or to the left at all. Okay. In the second quadrant, we start talking about angles that are greater than 90. So in this case, if I put the 60-degree reference angle in here, by reference angle I mean referencing how many degrees from the horizontal. So this is going to be 60 degrees back from the horizontal. So what is this horizontal over here? If I go all the way halfway around the circle, how many degrees is that? That would be 180. So right here, this is 180, which might be helpful to put this in here as 0. So that's 0 degrees. This is 180 degrees. So if we think about going 60 degrees back from 180 degrees, that is going to be an angle of 120. Okay, so now what is the sine of 120 degrees? Well, if we look at our special values here, the adjacent side to 60 degrees, or the cosine of 60 degrees, is 1/2. But since we're looking at a coordinate grid, it's to the left 1/2. So I don't want to use positive 1/2. I want to use negative 1/2. And so our cosine values in this quadrant are going to end up being negative because they're all to the left, which is negative on our xy axis. The sine value, opposite of 60, is going to be positive root 3 over 2. Because we're going up, it's positive. So what we've determined here is that the cosine of 120 degrees is equivalent to negative 1/2. And if you type that in your calculator, you can verify that. And the sine of 60 degrees is positive root 3 over 2. And so there is our next spot on our unit circle, our nice neat 120 degrees, which is 60 degrees from the horizontal in quadrant 2. Our next spot on the unit circle is going to be a 45-degree reference angle. So that would be 45 degrees back from 180. So if you subtract 45 from 180, you get 135. And so then we can determine the sine and cosine values of 135 as negative root 2 over 2 and positive root 2 over 2. Notice the sine is positive in this quadrant and the cosine is negative. The next stop is 30 degrees back from 180, so that would be 150 degrees. And 150 degrees would have a cosine value of negative root 3 over 2 and a sine of 1/2. And this pretty much completes quadrant 2, all the special values. What about 180 degrees? Well, that's one of our nice, neat values right on the radius. And so that is going to have a, let's see, a cosine of negative 1. So it's all the way to the left, the full 1 unit. And it is not up or down at all. So the sine value is going to be 0. So if you want to know the sine of 180 degrees, it's 0. Okay, in quadrant 3, we're going to look at the same type of situation. 30 degrees, but it's not back, it's past 180 degrees, the horizontal. So that would be 210. And so 210 degrees is going to have a cosine value of what? So how far to the left did we go? Well, that's the long one. So in 30, 60, 90, you have a short one, which is a half, a long leg, which is root 3 over 2, And so that's going to be negative root 3 over 2 to the left. And it's also going to be negative 1/2 down. So when we talk about values in quadrant 3, they are all going to be negative. So the cosine is negative in quadrant 3, as well as the sine. So everything in quadrant 3 is going to be negative. So at this point, things are probably getting a little repetitive, and you're probably seeing some patterns, which is good. 45 degrees past 180 is 225 degrees, and the cosine and the sine are both going to be negative root 2 over 2. So what is the cosine of 225 degrees? Negative root 2 over 2. Again, that can be a decimal. If you put it in your calculator, you would find the decimal equivalent. And so what we're going to do now is we're going to go ahead and just generate the rest of this circle. Okay, so I will fill in the next value on the unit circle, which would be 60 degrees past the horizontal. So 60 degrees past the horizontal is going to be 60 plus 180, which is 240. And all these values you'll become pretty familiar with. As long as you do your work and you have enough repetition, you should have no problem remembering these values. So this is going to be 1/2 to the left. It's the short value of the 30, 60, 90. And then it's going to be negative root 3 over 2 down, which is the long value of the 60 degree, 30, 60, 90. And so then the sine is going to be negative root 3 over 2. It's root 3 over 2 down. And the cosine is going to be 1/2 to the left, or negative 1/2. So that completes quadrant 3. And now we have a special value. We come to a multiple of 90. So what is 30 more degrees, or 90 degrees past 180? And that is going to be 270 right down here. And 270 is going to have a value, a cosine value of 0, because it is not to the right or to the left. So the cosine of 270 is 0. And the sine of 270, the sine of 270, let's see if I can get that out of there. Oh, there we go. Sine of 270 is going to be down 1, or negative 1. So now we just have quadrant 4 to generate, and then we'll have completed our whole unit circle. So we're going to go back from the horizontal, and what that means is we'll just start with 30 degrees. So what is, oops, I gotta get the right triangle here, this one. 30 degrees backwards from, now I haven't put this in yet. 0 is the same as 360. They're exactly the same because you start at 0, you go all the way around to 360. So what is 30 degrees back from 360? That's going to be 330. So right here, this spot is 30-degree reference angle at the horizontal. We're in 4th quadrant, so it's 30 degrees back from 360, which is 330. And again, the cosine is going to, or the sine is going to be negative because it's down. And the cosine here will be positive because it's to the right. So it's to the right root 3 over 2. And it is down negative 1/2. So in this quadrant, your cosine is always positive and your sine is always negative. Okay, we're getting closer. The next one would be the 45, 45, 90. So if I go back 45 degrees from 360, I'm at 315. Okay. And let's pop the other one in there too, because this is getting pretty repetitive. If I go back 60 degrees from 360, I get 300. And so there I've completed my full unit circle with all the values. And we just need to go ahead and complete this. So I'm going to go ahead and finish this up, it gets pretty repetitive. So I'll pause it and complete the circle here for you. And so here is the final product of the unit circle. So what essentially is all this stuff? Well, let's kind of recap. Let's review. The reason why we made the unit circle was to start talking about values of sine and cosine that are greater than 90. And so we really can calculate the cosine and sine of any angle because we can just keep going around and around the circle. So 0 to 360 degrees, here's all these special triangle stops. We haven't talked about all the angles in between yet, but these are just kind of nice, convenient ones for us to look at so we can explore the values. What are some things that we know that are true about cosine? Well, if your cosine value in the first quadrant, it's positive. What is cosine in the second quadrant? They're all negative. They're the x values. Third quadrant, cosine's negative. Fourth quadrant, cosine's positive. Just like the x and y values. Sine from 0 to 90 degrees, or in the first quadrant, is positive. And from 90 degrees to 180 degrees, it's also positive. So the sine is positive from 0 to 180, and sine is negative from 180 to 360. So I'll put up here a plus and minus sign to indicate those values. So you can see here that in quadrant 1, the cosine's positive, sine's negative. Quadrant 2, cosine's negative, sine's positive. Quadrant 3, cosine's negative, sine's negative. And in quadrant 4, the cosine's positive and the sine's negative. So I know this is a lot of information and there's definitely a pattern to it. And so this will be the first video just getting into the unit circle. I'll post a follow-up video here that will be essentially going through some practice problems with the unit circle. Thanks for watching.